today is the last day of the, not the last day, last week of lecture. So next week, originally, will be the final project presentation because we have too many students in class, so we don't have that to fit into one lecture. So instead of present here in person, I would like you to just record a video, 10-20 minutes, just introduce whatever you have developed, whatever you want to show to the class, and then just upload the link to the video on Canvas. That's it. So just follow the final project submissions. You will be just basically the link to your report, the link to your documentation website, and also the link to your video. You can upload on Google Drive, Dropbox, whatever. But make sure that the link is publicly accessible. So when I click the link, I need to be able to see the video. Otherwise, I'm going to take points off. You're welcome to upload that to YouTube and then embed your video into your website or your GitHub, whatever works for you. So you'll be something similar, like, again, be something like this. For example, you can have some short animation, GIF animation. You can also embed, for example, your video on there if you want to. So, but the final product will be something like this, not as complicated as this. Yes?
Do we have to do a video, or can we choose to do it in class if there's not that many people?
Because if everyone is doing, I want to be everyone doing the same. But because last week we only have one lecture, but we don't have enough time for everyone. So because if each one like 10-15 minutes, you're going to have at least basically more than 2 hours. We don't have enough time for that. So do you prefer to be in person?
Yes.
How many of you would like to be in person? Only you?
Only me, I guess.
Okay. Yeah. How many of you want video? How many of you want in person? If you really want to, we can come here in person too. Like for some of you who would prefer to be in person. No one? But nevertheless, I like to do the video because I think you can do that not just for the class, but you can do it also for people around the world. So if you really want to in person, you can do that. But I still want the 10-minute video just to be fair to everyone. Okay. So let's decide. How many of you would like to be in person next Tuesday here? Just for the presentation, if any of you would prefer in person. Huh? Yeah, I still want a 10-minute video. As I said, you want to have that on record. In person, once you finish, it's gone. There's no record, so it'd be nice to have a video. But this is more like the workflow in the future. If you introduce anything new, you can record a short video, couple minutes, and then you can put it on your YouTube or you just share the link. It doesn't have to be public. But if somebody can actually go to a website to look at that, I think that would be great. Okay, if no one wants to take one, I think I can still be here next Tuesday if you want to, but I will assume everyone just want to do a video. Yes? Tracy, do you?
We have to do a video now, so then I would just rather do that.
Okay, then everyone to do a video. So use the time to do the video. But again, all the video will be posted on Canvas. So you're welcome to watch how your classmates are doing. And again, you don't have to do too long. I mean, 10 minutes, 15 minutes, up to you. Depends on how much content you have for your package. But at least, couple minutes, right? Just to introduce what's the functionality for this, how do people get started, how to actually launch the notebook, something like that. And just showcase how to use that briefly. You don't need to be very comprehensive trying to cover everything, but roughly around 10 minutes is fine. Any other questions? So this will be the last week of lecture, today and Thursday. Then you should have time for your final project. If you need more time, let me know. I'm more happy to, I'm very flexible on the deadline. Any questions? Please ask. Okay? Any other questions? Hannah, just to briefly recap what we talked about. So this will be the last week of lecture. we will not have lecture next week. So next week is for you to do the final project and then record a 10-minute video and then share on Canvas. Okay, you can upload to GitHub, not GitHub, Google Drive, OneDrive, Dropbox, YouTube, whatever you like. Yes?
Did you already talk about the final exam?
Yeah, the final exam will be similar to the midterm, so there will be only a couple questions, allow you to do that interactive. So I believe the final exam is what day? May 11th, so it'll be next Tuesday? Thursday, next Thursday. Again, it will be similar, and just it will be open book, so basically everything is similar to the midterm. You can do whatever you want, but you'll be open book, and then it'll be something integrated into your package, just like one lab assignment, and all the lab assignment we have done. So if I ask you, for example, or add this functionality to your package, and then use a notebook to demonstrate, something like that. I haven't finished the question yet, but if you need more questions, let me know. But probably just maybe 3 or 4 questions, something like that. A couple questions.
You'll be in here.
Yes, in class. Yes?
So did you say that you were pushing the final project deadline back?
Oh, no, wait a minute. I'm saying that if you need more time, let me know. I can give you more time. Okay? But make sure you can submit everything before I give the final grade. Once I give the final grade, then it's done. All right? So that's all for the final project. So we'll be next week online. And then the final exam on May 11th. So make sure you don't know, to prepare for the final exam, make sure that you are able to, for example, if I go online, you can source basically know how to adapt the example from other packages or from different whatever, and then put it into your package. So you know how to deal with the dependencies, how to actually demonstrate. So today we're going to showcase some of the things you can use to help debugging, because from some of the lab assignment that you have submitted, some of you have the notebook actually showing up on the website, some of you didn't. Some of you have the map interactively on the website, some of you didn't. So today I'm going to showcase how you actually make your stuff interactive on the Google, on the Mkdocs website. And I'm also going to show you how you can test the website locally, because sometimes if you push to GitHub, it turns out it doesn't work. But you can test everything works perfectly before you push to GitHub, push to the website. So the first thing we're going to try out today is the Mkdocs. So everything that we see from the website right now, as you can see, is based on the Markdown and Jupyter notebook. And you can have all kind of menus. So if you go to, let's say, how about this one, notebooks, and then intro, right? You will probably notice all my packages, all the maps are basically interactive. It's not static. So if you want, you can really do something very similar, but you will need to use Folium. As I said, IPyLib doesn't support this website, so Mkdocs cannot really build, because IPyLib that you will need the back end, you also need the front end. So the website you see on the browser is the front end, Python is running in the back end. When you deploy to the website, it becomes a static HTML. There's no back end anymore. Everything is just the front end. So there's no like server running behind to write the Python code. That's why it doesn't work. But you can convert things to HTML. So in today's lecture, I'm going to show you how you test the website on a local computer, how you build the website, make sure everything works perfectly before you put to GitHub. Otherwise, you're going to see all kind of errors on the GitHub actions. And I'm going to use the one that we developed, so GOS demo, and this will be the repo. And once it is open, let me show you where the file actually is located. So here, if you look at the documentation, the GitHub repo, right? This is the Mkdocs that instruct the program to create a website. And so the site name, the site URL, the repo URL. If you go to GOS demo, right? So look at this one here. Those links are important. Basically, the upper right corner, if you click the GitHub, right? Lower left corner here. See this one? This is the URL. So this one actually coming from here. And this is the homepage. This is the name of the site. in here. So upper left corner here, this one is control. The name is control. If you want, you can change it. And there are a couple things that you want to make changes on your website, or every time when you add some new stuff into your package, make sure, for example, if I have a notebook, so here I'm going to add a new item. So this is the examples. I have 1, 2, 3, 4, 5, 6, 7. You come back to the website here, examples, right? So these are all the links, all the examples coming from the Mkdocs. And all the example, basically the website is built under this docs directory. So everything is under here. And you want to have some docmd files. Docmd file basically is just markdown. And so for the FAQ, the index, you're going to see something in there. But for this one, the API reference, this one here doesn't have content. So this one is built automatically based on your source code, right? So we have GeoOS demo module, volume maps module. So if you come back to here, right, within here we have index. This one have all kind of text. But for the GeoOS demo.md, it's pretty much empty, just 2 lines of this. So this one here, this one controls what the text going to show up on the website. And this line, colon, and then space GeoOS demo.geos demo. So what this one is doing, basically, is asking it to read the .py file, extract all the doc string, and then construct the website. So it comes from here, right? GeoOS demo. This is the name of the package, and this is the module, right? So GeoOS demo. You notice that we don't actually have anything in there, just this line. And then this is what this is what it's going to look like when the website is being built, right? So we have all the functions in here. You have see the source code. You also see the table. So some of you didn't have the table. That means your doc string is incomplete. You should have all the automatic extract from the source code. So if I come back to here, look at this one. If we have source code, a doc string here, the first line is just basically the description of the function, and then args, basically the arguments, indented, and then have whatever arguments you have. Everything here, this function is going to be extracted, and then it's going to look like this one. So source website source control. Right, so we have 1 argument. You can have source code, you can have the description. And later on, if you add more modules here, something .py, then in your documentation here, you want to create another whatever name .md, and then within there, this one, basically whatever module, so within the module of your name of your .py file, and then GeoOS module. So this name here need to be exactly the same as whatever module that you created in here. So I can, for example, right now I can create a new module, new file, and how about this? I would say maybe common .py, right? And within there I can add all kind of function. So I can maybe df print, let me generate it, or maybe hello world. Okay, so here I can look something like this, autocomplete, or maybe change to another one, greetings, so they can have a and here I can pass in a name, right? And this is the function. So then you can print out hello name, something like that. So usually after I add the function, I would just come here, right click, generate doc string. You see, really quick, and then greet the user by name, right? And then the name str, the name of the user, Control S. So this is the function that we just added, and assume right now we finished this one. You can continue to add more functions, and once you are done, if you want the documentation to show up on the website, you come here on the docs website, I think the easiest is just to copy the content. So we can go to the existing one and then just select the content, copy. Up here, right click, new file. So this one will be the same, pretty much the same, use the same name of your module. So earlier we use common.py. So here we use common.md. Okay, and then just paste the previous content. So this one we need to change, right? We say common module and then common. So this name here, this one must be exactly the same as your Python file. But this one doesn't have to. This one is just the text going to show up as a menu on the website. So this one can be, it doesn't have to be the same. You can change to anything else or common functionality, whatever. So this one is eventually what's going to show up here on the API reference. Okay, so this is for the API reference, and you can add notebooks, you can add as many stuff as you want. And the other thing here I want to show you that might be useful is something under here, the plugin Mkdocs include source and also the execute equal to true. That means when the website is being built, if it is true, it's going to run your notebooks and it's going to generate all the outputs. For some of you, I think more than 50% of you right now, you probably turn that one off. So your notebook actually doesn't execute when it's running on the GitHub. Usually it's recommended unless the notebook is running really long. If there's a small script for you guys right now, you're able to actually set this one to true so that it can test you whether your package is running correctly or not. If it turns to false, you never know because the notebook is not executed when it's being built. So you probably want to double check this one. And that's why on the website here, right, the leaf map, you see everything. If it is execute equal to true, when you go to the notebook, you will see that in sequence 1, 2, 3, 4, 5, because it runs from the beginning to the end. And for most of you, not most of you, I mean some of you, you will see that some of you see the number is not like 1, 2, 3, 4. It's skipped because you run it on your computer and it just push it. It's not, the notebook is not run by GitHub. The notebook, you execute the notebook and then you generate this, the result. You just push the result to GitHub. That's usually not recommended because your file will be unnecessarily large. If you have some maps in here, when you generate the website, your notebook will be big. But if you clear the outputs and then you upload to GitHub and then let GitHub take care of all the execution, then it's a much better way. Okay, so this is how you create new modules and add to the website. Yes?
So we should include the execute true
Yes.
in our script.
Yeah. But the downside is that you're going to run into errors. So whenever you push to GitHub, sometimes you're just going to do a red cross marks because the notebook might be missing something, the module might be missing, the package might be missing, or the file path might not be available. So this is especially true. I just created, for example, the lab 8 and lab 9. Some of you have the notebook running and then 8 images, but the image, the file path actually doesn't exist on GitHub. So if the file path is a local computer, your notebook will not able to run. And this is how you actually, this is the nice way to help you make your stuff reproducible. If you don't execute the true, your result might not work. Your notebook might not be reproducible. Basically, when people click your notebook and then launch on Google Colab, if it runs, that means it's perfect. If it doesn't work well, that means your notebook may have something wrong. Either the file path, the packages, or something like that. Then you have to fix it. So I would recommend that you turn this one to true, and then just look at what kind of things you might need to fix. So next, let me show you how you can figure out whether it works or not. If you look at the notebook here. So next, let's find out how we can actually test this one on a local computer. So they can build the website. You can see the website visually. If you go to your package and then .github workflows .docs.yml, okay. So this is where you actually see how GitHub runs your website. If I go to my GitHub repo and then actions, on the left side here, you should see some of these items. So the website is actually being executed by this one. So docs, if you click in, every time you push something or you release a new version, GitHub runs the website for you. So basically re-render the website. And if you want to see the details, you can click in. Again, sometimes if you run into error, you might not see the red cross marks. Don't panic. Just click in. See what's the error message. And then you will know how to debug, right? If for this one here, if I click in and then click in, right? And then see it's running step by step. So it's actually coming from these instructions. So this is the documentation. Basically, you can think about this is the command that you ask GitHub to run for you. So it's going to create a virtual machine. It's going to install all the dependencies. And the last step basically is going to run Mkdocs to build the website and then deploy it to your GitHub pages. And if you come back to here, right, step by step, run this, install dependency, pk text, run this one. And everything works fine except the last step is going to throw the errors. And if you look at the error message, sometimes it can be very intuitive, sometimes it's not. So, but at least you give it some idea which step is causing the issue. Then you go back to fix it. It's a notebook. So because here, if you look at the documentation here, running, converting the notebook, IPy widget, and then from here, it's going to throw the error. So that means most likely the error comes from this IPy widget.ipynb. So that notebook caused the issue. Then you need to fix it. You can either skip this notebook or you need to fix the error in that notebook. So if you look at others, so go back to here, actions, docs, and then come here. This is something you want to see, right? Nice, everything works perfectly. Green check mark, that means you don't have to worry about that. So once this one is passed, usually it is going to deploy to your website. So you will deploy the website. You are going to see this one, pages build and deploy. That means you're going to convert all your notebook into HTML, and then it's going to deploy the website. So usually you should see this one at the bottom here, deploy, and then https username.github.io/ the name of your package. So this is usually all the step. And what we're trying to show here is how you actually run this one, how you actually build the website locally, so they can see where is the website renders as expected or not. Okay, but in order to actually to build the website, you're going to see here, these are all the steps. So you need to install the package, you will need to install the requirements.txt. Also, you need to install the Mkdocs material website. So these are all the dependencies in here. And this is what we need if we want to build a website locally. So next, I'm going to show you how you can build a website so they can test it. Okay. And there are some other steps in here. This most likely you already have that because you have been installing the package on your computer. You have been running it. Most likely you already have these dependencies. So what we need is this one. If you go to your GitHub repo and then .github workflows docs.yml, can you find this file? And then once you here, use it at the bottom here, you just copy this new line. This is only one time only, so you don't have to install all the time. You just install once, then you you should be able to build your website. So I'm going to copy this one, then come to your repo, or just open your terminal, and then we're going to install these dependencies so they can build the website. Okay, so conda activate GOS. Once you activate the environment, after you copy the line, just Control V, pip install Mkdocs material, Mkdocs strings. You will see these are actually all the packages we use to build the website, and also extract the doc string and then put in the website. Control V and then just hit enter. Also the Mkdocs Jupyter plugin, right? So those are all the dependencies that needed to build a website. The reason that we didn't put the dependencies in the requirements.txt here Why we don't put all the dependencies in here? So pip install a bunch of other stuff. Why don't we just put here and then let the user install all those dependencies? Yes?
The user doesn't need this stuff for the website.
Exactly. The user doesn't need to build the website, right? So you don't want to add unnecessary packages to your requirements.txt, because these are all the stuff that when user pip install your package, it's going to install everything. So you need to minimize the number of dependencies you want the user to install. The more, the longer it takes, right? Or the more challenging. If you install some like raster IO or GDAO in here, it's going to cause trouble because some of those packages doesn't work on all platforms. So if you want to maximize the usage of your package, make sure that it's easy to install and don't put unnecessary one. Although it might work on all the computers if you include all those dependencies, but it's unnecessary. So all these dependencies listed in here should be the package that you use in your package, not you build your website. That's why we don't put in here. Okay, you see, it's done. So once we finish this one, now we can build the website. Okay, so how do we build a website? We're going to use the Mkdocs. If you just type Mkdocs and then hit enter, it's going to show you the help documentation. If you don't install the packages, the dependencies, you will not see this one. So when you type Mkdocs enter, you're probably going to see some error messages. Can you see this one right now?
Were we supposed to do the pip install inside of our package?
Yes, inside your conda environment. Don't pip install into the base environment. Conda activate whatever environment and then pip install.
But did it need to be in our folder for our...
No, you don't have to. But when you're trying to build a website, make sure that you get into your package folder. Otherwise, it won't work. Okay, so for example, let me show you. If I close this one, and let's say I'm going to go to my downloads folder. So if I right click, right, I can open it again. I can here conda activate GEOS. I can also type Mkdocs in here and it should work. But if you try to build a website, it doesn't work because under the downloads directory, there's no website document. There's no mkdocs.yml. It's actually within, you need to get into the folder. So when it's building a website, it's actually looking for this file. So your direction need to have this file. For now, let's look at this one here. It says Mkdocs and then build GPS deploy new serve. So look at this one, build. We can either use build or serve. There's also another one called GH deploy, so GitHub pages deploy. So this is the one we use on the website. If you come back to this YML here, look at this one, Mkdocs, GH deploy, and then force. So this is basically telling GitHub Actions to build a website and then deploy that to your GitHub pages, to your website, and then overwrite everything. This force means overwrite everything. Otherwise, sometimes it might not work because there might be some conflict. So on our local computer, we don't use this one. We actually use Mkdocs build or Mkdocs serve. So either one is fine. Mkdocs build basically build a website, and then you can go into the directory, just double click to open the website. Mkdocs serve actually automatically open the website for you, so you can take a look. So now let's see what's the difference is. If I'm on the website on the here, so now we can just Mkdocs build. Again, this won't work because right now under this directory there's no file in here. So if you press enter, config file Mkdocs YML doesn't exist, right? So we need to get into this GOS demo folder. So what we can do, cd GOS demo. Okay, and now we can use Mkdocs.build. Okay, also make sure that on the left side here, this is your conda environment where you install Mkdocs. Okay, so now Mkdocs build. Before I hit enter, I'm going to look at this one here. If you look at this directory here, once I execute, it's going to join a new directory called site, SIT. So pay attention to here, Mkdocs build, and I hope it works. It's running. So this is pretty much the same thing you see from here, your GitHub Actions, and then Docs. Then go to any of those. Essentially is the last step here. You see the content in here, and also this one. See that? All the content. So it's converting. Oops. I see. So now it's going to show you the following pages exist in the doc directory, but it's not included in the nav documentation. And so there's error reading the pages, examples, untitled doc, IPYNB. So now you see it fails on my computer. That means the website cannot build. And this is something you're going to run into when you kind of build a website. And here, examples of untitled IPYNB. I can go back to here, and because I have some of the files in here. So let me check this one. Check this one, the untitled one, because I don't really need it. So I can delete the file. Basically, when you're building a website, make sure that you have commit all the changes. If there's something that's not supposed to be, you can actually, let me delete this one. I don't need that. I don't need this one. Now let's build again. So if you already push the changes to GitHub, you might need to revert some of the changes. And this also might give you some warning. For example, GEOSDemo.IPYNB, IPyNotebook. You might give you some warnings, but as long as there's no error messages, you should be fine. So you want to make sure that it runs locally, everything works fine. Oops. Volume.IPYNB. Okay. If it says like the module doesn't exist, I can. Do you get the same error? Did any of you get the same error like this one?
Mine's still going.
Still going?
Yeah.
If your package sometimes takes a notebook takes a long time, it might run into error. So let me copy this one. Let me see if we can install the package. This is the normal process. You want to run into errors, and then you want to debug that, fix the error. Sometimes you might need to Google or ask ChatGPT to find some answers for you. Hopefully, at this stage, your package is not that complicated. It should be relatively easy to figure out what's wrong, and then just install the dependencies, and then you can just run, build a website. Everything works fine when I test it on my Linux machine, but on Windows, sometimes the dependencies might be different, so you might need to spend some time to do the debugging. Yes?
Mine said documentation build in whatever many seconds.
Is it done?
It's done.
Oh, okay, that's perfect. So if it's done, then go to, do you see the sites folder under here? Under your package? SITE? Yes?
Yes.
And then, I don't have it, so I cannot really show you that. I know what's going on. So this is kind of a acting wheel. I might need to create a new. Okay, it looks fine. Let me try it again. The error that's showing there actually is not the one that I needed, so I'm not sure why it's causing the trouble. But once you have the sites folder, if you click in, there should be like index.html somewhere under a subfolder. Can you find it? And then double click that one. You should be able to open that in the browser. Do you see the website? That's exactly the same that you're going to see when you deploy to GitHub. So in this way, you can look exactly how the website looks like. If it's not doesn't look good, you can change it, and then you make changes. You review it again, and then it should work.
So I need to push that too?
No.
No.
You just test it. GitHub we build a website for you. Okay. So the reason why we want to test it locally, because we want to see if it works. But as long as you have this website, GitHub is running this step just like what you run on a local computer. So The reason that you want to test it is that potentially this line might run into error. So you get to know that in advance on a local computer, but you don't have to push the stuff. You don't need to push the site folder to GitHub. It's unnecessary because GitHub will generate the files for you. Yes?
So then I'll delete that folder.
You don't need to delete.
No, it just will.
It will stay there. It will not push to GitHub. So if you open your Visual Studio Code, probably you won't see the files in here. The reason for that because we have the .ignore.
Oh, okay.
.ignore. So this one basically ignore all the sites. If you see this one, if you scroll down, you might see a site here. Mkdocs documentation and then /site. So basically everything within this folder is being ignored. It's not being checked. So it will not push to GitHub because this is unnecessary because GitHub will generate the file for you. You don't want to create and upload unnecessary files into the website. It's kind of slow, but you see right now it's running just fine. So once everything is finished, I should see the sites folder, and that's the one that you can always figure out whether the website is functioning or not. If it fails, most likely GitHub will also fail. Okay, so it's not, right now is the time for you to, if you want to test it out, go to your Mkdocs YML, and then from here execute. If it is false, try to say it's true, and then run Mkdocs build, see if it works. If it works, then your website, all the code will run perfectly. If it doesn't, that means something is wrong with your code, so you might need to fix it. It's taking more time because I have many notebooks within my directory here. You see, I have the examples. I have the Python, like I have over 20 notebooks, so it might take some time. But this is nice because this is so-called continuous integration or testing, because you design the function, you test the function in a notebook, GitHub runs the notebooks. So if the function doesn't work, GitHub will let you know, and then you fix the function. Okay, it's done. It's going to say documentation built in 197 seconds, so it's roughly 3 minutes. Now if I come back to here, see this one, site, double click, and this is basically the website. So if you go to your GitHub repo here, let me show you where the website actually being hosted. So earlier you see the Mkdocs GH pages deploy. Once it's deployed, it's going to generate a new branch called GH pages. So this is where actually the website is being hosted. The website is not being hosted here on the master branch or the main branch. It's being here. If you click the GitHub pages, look at these files. Do they look similar like in here? Right, for HTML, index HTML, you see name, and then the site, right? If you also see the directory name, assets, changelog, contributing, examples, right? Exactly the same. So the file directory is the same as the website. That's why you can see the website is basically being built and then create a new branch and then push the content to that branch. So the GitHub pages branch is the special branch that is going to GitHub will know, and then we link the website. So when user go to your username.github.io/ your package name, is going to redirect them to this content. Okay, so what I'm saying, if your content here, everything works fine, your website works fine. If this one fails, your website will not generate new content, so you will fail again. So this is how you make sure everything works fine. And I can also just double click this one. You see, now this one runs on a local computer in here. See users, okay, but I can click it. When you click on local computer, you will see this one. It doesn't actually show you because Google Chrome might not automatically render the HTML. But when you deploy to the website, when you click that, it will automatically direct it. But for here, you might need to click index.html. So, but on here, if I click anything, it should work directly. Okay. But at least you can see whether the website works or not. You can also search it if you want to. If you go to the site, right click, and then properties, Look at this. So the size is 22.7 megabyte, right? So this is the website, the entire content of the website, and this is called static HTML. So basically, there is no interactive content. You'll be just static. There's no Python function running behind the scene, and that's why IPyWidget actually doesn't really work in here, because once it's converted to HTML, everything will be static. But I can click examples, volume, and then click this one. You see the map? This one is interactive. It's HTML because the volume converted the code to HTML, and now it runs here. But for your package, if you want to have some interactive map on your website, you want to have similar function under your volume module rather than your main module using IPyLeaflet. So you need to have similar function. For example, add base map for your main module using IPyLeaflet, and also add base map for your volume module. So in that way, when you build a website, you want to have the interactive content on your website, rather than if you go to IPyWidget and then click here, your website pretty much is going to show something like this, and it might show the content, but the map will not showing up in here. But you should see the output, right? If I select this one here, GitHub Actions run the notebook, or my local computer build the notebook and runs from the from the beginning to the end. So it's up to you what you want to do. Again, if you come back to this one here and look at my module, right? I have the main module GOS demo, but everything here is using IPyLeaflet and IPyWidget. Your map will not show up on the website. But for this one, the volume, it can. But volume is quite limited. Volume is good for building website, some interactive content. IPyLeaflet is more good for notebook if you want to have some interaction with the map. For example, you just click, change your base map, you add some new stuff, you want to use IPyLeaflet. Volume here, right? I have similar function, add tile layer. You can have add base map, up to you whatever you want to add. Okay, so this is how you build a website locally. If something is wrong, you want to fix it. Okay, also in here, let me show you something. Here, there's execute ignore. Do you see this line on your doc.yml? On this file, do you see this line on your docs.yml? So this means that you can, if some of the notebooks that's very challenging to run, or it takes a really long time, I can skip that so that the notebook doesn't actually run. Right now, if I go to my website here, if I click any notebook, you're going to see 1, 2, 3, 4, right? It's being executed. Also for the Python basics, right? If I come to here, get started, and if I click this one, or not the notebook, you click this one. Not this one, maybe. How about this? Introducing list. Alright, you're going to see this notebook is being executed. Right now, if you decided that, oh, it takes so long to run, I want to skip this notebook so that Mkdocs doesn't try to run the notebooks. You can skip it if you want to. So let me show you here how you can skip stuff. Again, pay attention here. Right now, I'm showing here the Python notebook examples. You will see the square brackets. That means this notebook it was executed. Now I can try to ignore that. So if you go to this one here, execute. Let me move it up a little bit. So execute, ignore. That means you can ignore any files that you don't want them to execute. So here, you can either put, I think you need a list. So just square brackets, and then by comma, it's going to ignore all the examples. So here, docs, right? Under the docs website folder, I have the Python, I have the examples. Assume that, okay, I have too many notebooks in here. Right now, I don't need to run this notebook because I just want to test the website very quickly. I can ignore all of them. So what I want to here is the square brackets, and then you can double quotes, then the file path, right? So the file path is everything relative to the docs folder. So it will be Python something.ipynb. So they say I'm going to skip all the notebooks within there. You'll be Python, okay, /start.ipynb. You probably don't have this one yet. That's fine. And next I can skip more. So here examples, right? I have maybe how about this? I want to skip this raster.ipynb. Assume that the raster notebook doesn't work well, and right now I just want to update it. I don't want to push to the website, so that GitHub Actions can build a website. I can skip this one. So here you're gonna put comma and then double quotes again, examples /raster.ipynb, Control S. So what this one is doing is telling Mkdocs that when you are running the website, execute all the notebooks except this one specified here. I'm going to skip all the notebook under the Python's directory. I'm also going to ignore the notebook in the examples folder, raster.ipynb. And before I run that, let me show you here, right? Examples, raster.ipynb, HTML. For now, you see here, right? You see the notebook, blah, blah, blah in here. And then you're going to see all the text in here. Right now, I already ignore. So this will all be clear. If I come back to here, Mkdocs build again. This time should be much faster because I skip a lot of notebooks. The website should build pretty quickly. But the difference is that now you have no idea whether your notebook works or not because you skipped it. Usually it's not recommended unless sometimes it's very, notebook is very complicated. It takes a long time to run. Eventually GitHub Actions time out, and this is what you want to do. Let this one run, and I can show you the example here under the DivMap website. If you go to the GitHub repo, similarly, if you look at the Mkdocs YML, and if you look into that, I probably skip a bunch of notebooks here, right? Execute, ignore, and these are some of the notebooks that's constantly giving troubles, doesn't run well, takes a long time, and then just skip that because I don't want to fix the error every time. So now let's see if it finished. It's still running. It's almost there. If you see any errors here, look at the error message and then try to look into that, see if you can fix that. If not, just Google it or just Google ChatGPT and then see if the ChatGPT can help you fix the answers. And you see the raster here on the left side here. This is where you can see whether it's executed or not, right? So raster.ipynb, I ignore it, right? Execute equal to false. That means this notebook is not being executed. All others are executed. And although the notebook is not executed, but it's still going to convert the Ruby notebook into HTML. So it might still take some time to convert it into the website, but it should be much faster because you don't have to actually execute the entire notebook. You just convert it instantly. Right? So now you see here, execute equal to false. Like those notebooks are not being executed, but it still takes time to run the notebooks and then convert to the website. Eventually, once it's done, you should have the site's directory updated, and then you can start looking at the website, see if it works or not. If everything works fine, then you can start pushing the stuff to your GitHub repo. Again, you're welcome to inspect your GitHub repo under your package name and then GitHub pages. And this is where all the website is being built. You can also look at the this is only one commit. So when you push multiple times, most likely you want to have multiple commits in here. Right now I only have one because I didn't push it so many times. But for you guys, you might have multiple because every time you update the website, it's going to be updated. Okay, you see, right now it's done. So earlier it was 197 seconds. Now it's only 150. So we save almost like 40 seconds. And click here, site. index HTML, right? So earlier we ignore execution for all the Python examples and also the raster.iplmb. Now let's come here, take a look. Raster.iplmb, see? In something, this one is no longer, you don't see 1, 2, 3, 4 in there, it's not executed. And you also don't see the output in here, right? But if I click other notebooks, HTML, you see, out, in, out, and then that means your notebook is being executed. Similarly, if I go to Python examples, right, all the examples under this one, I ignore it, so they're not being executed. So if I come back to here, click, you see, it's no numbers in here. And for some of you, for your lab assignments, if you go to your website, you will see like maybe 2, and then maybe 4, and then sometimes it's reverse, and sometimes it's no. That means you did not execute the notebook on your website, on the GitHub Actions. If it's executed, it should be by sequence. And also you want to minimize your content. So for example here, if I run the notebooks and then execute it, your notebook file is going to file size is going to change. So basically your repo will become unnecessarily large if you keep putting content, execute the notebook, and then you don't clear the outputs. So the best practice for you, pay attention to this one. This is going to affect you, okay? Right now, you're only developing a package, just getting started is okay. But when you try to develop something that becomes widely used, you want to minimize the size of your repo. So don't include content in your notebook unless necessary. And don't include the output content in your notebook unless it is necessary. So I'm going to show you the differences in here. If I go to right now, go to my repo. So all my notebooks are under the docs and then examples. Okay, so look at this one here, right? Volume right now is 3 KB. Okay, so pay attention to this one. Right now I'm going to run the notebooks, and then you're going to generate the output. The file size will be increased dramatically. And if you directly push the notebook to GitHub, the content is there. Even later, if you delete it, the content is in the history. The file size is there forever. So if you accidentally add some GeoTIFF, add some CSV, add some shape file, last one into a repo, you are done. There's no way back. You probably need to recreate another repo because you can delete it on a repo and then commit again. Your repo size will not decrease. Everything is permanent. Okay, that's why we want to use source control. You cannot actually eliminate the commit. So let me show you what do I mean, right? Assume this is the website I'm building, and I have the notebook in here. I go to the docs, and then I'm going to execute this one. So volume, right? Again, let me show you the size, all my files. So right now, what you want to track is to go to your docs examples folder and look at the file size. If you see many KB, many megabyte, it's wrong. It's not supposed to be, okay? It should be very tiny. All the notebooks should be only a couple KB. If you have MB in there, it's bad. You want to actually clear the output. So now, let me show you here, right? I didn't run the notebooks. Right now, it's very clear. But if I start running the notebooks and then execute this one, execute, display the map, right? Everything works fine. Let me run all of them. Assume this is how you test your package on a local computer. You run the notebooks and then you click Ctrl S to save it. Before you push this to GitHub, make sure you clear all the outputs because you want GitHub to take care to build the website for you. GitHub can generate large files, but it doesn't contribute to your repo. Your repo will still be pretty tiny. But if you do this way, just click and run that and then push your notebook. If you come back here again, where's the volume? Look at this one right now, right? Earlier it's 3 KB, now it's 21. It's 7 times. Although it's still pretty tiny, but it can increase dramatically if you continue to push your stuff into the notebook. So you don't really want to do this. Before you push, make sure that on the left side, if you see anything changes, for example here, right, Mkdocs YML, this one, if you click, okay, this is what I want. So it's fine. I can click it to commit the change, to put into the staging area. But if I click this one, you're gonna see the differences, right? You add all the outputs. You don't want that, okay? I want to make it very clear, especially if you're trying to contribute to other packages on GitHub, right? Not your package. If you're trying to contribute, you add some notebooks for some examples. Make sure you clear everything, especially if there's some sensitive stuff in there you don't want to put in there, right? So this is unnecessary because GitHub can run the notebook for you, generate the content. It doesn't matter how big it is. It doesn't contribute back to your repo. So 7 times file size increase is not good, okay? Especially if you have large files, you have add a GeoTIFF, add some GeoJSON, add some CSV. Don't do that. It's not good. So I'm going to come back to here. Before you finish submitting to GitHub, I want to make sure you clear all the outputs, and then you're going to see the right dot here, Control S, and on the left side here, this one might be gone. You see, basically, Git can detect like there's no changes. Even earlier you run the notebooks, there's no really meaningful changes in your notebook, so it's not being detected as changes. Now, if I come back to here, right, volume.ipoMB, it returns to 3 KB again. That's good, okay? So make sure that before you push things to your GitHub, don't increase the file size unnecessarily. You only add the files unless it's really required. But you can allow GitHub to build a website for you. The file size doesn't matter because when user clone your repo, they're going to clone the master branch. As long as the master branch is tiny, it's fine. So if you really want to try it out here, if you want to look at it, right? Now we're under this website. So what you can do is I can select all the files and see how big is the repo, right? But you need to uncheck the size directory and also the .git directory. If I right click here, 6.5 MB. It's not perfect because I have a local notebook. It's okay. But if you have like 650 megabyte, it's a red flag. Okay. When user trying to pip install or trying to something, it's going to download the entire 650 megabyte. That's going to drive people crazy. If you have slow internet, it's never going to work. But if you look at the .git folder, this is where Git keep all the changes. And this one sometimes might be pretty big. You see here, 58.1 megabyte. No good, okay? I don't really have a lot of functionality. In total, your package is like over 60 megabyte. It's too big. I didn't know what I did there. Probably I commit some other bad stuff in there. But this is usually, if you want to check how big is the repo, look at the .git folder. The larger it is, the longer it takes for people to actually download the repo. So you don't really want to do that. You can go in to take a look. Those are usually, you don't need to modify, but there might be just a lot of like large files. So you see, every time you make some changes, you're going to create a folder and then record the history. And this is what I meant earlier, that if you accidentally commit some large file into a repo, it's in there. It's not going to be deleted. Even if you delete the file, but it's in the Git history. So it's no way back. So make sure that before you commit something to GitHub, double check the list of changed files and make sure there's no like huge files. Especially if you have GeoTIFF, shape file, GeoJSON, KML, anything, something like that. Try to avoid to put it in your repo. You can create another separate one because not all the user will use the file. So I want to make it very clear. So those are some of the best practices you want to follow. If you want trying to develop something that you want it to be used by other people. Number one, don't increase unnecessary large files. Number two, make sure that the notebook runs perfectly, that there's no error messages, because when the user click to run the notebooks, if it fails, then it fails. It's your responsibility. So if I come back to here, go to this one, and volume. This one I don't have a GitHub Google Colab basis in here, but for other stuff, for example here, this one here, I can click the notebook, right? I can open this one in Google Colab, then I can start running from beginning to the end. So if you really want to try it out, most likely, if GitHub Action was able to build the website and run the notebook, so basically X equal to 2. If it runs fine, most likely it works on GitHub, but not always the case. The problem is that when you build it using GitHub Actions, you have the sample files and the sample directory, but those might not necessarily be available on GitHub because GitHub only has the file, only has this notebook. It doesn't have access to the content onto your docs folder. You might have some examples, you might have some data in there. So you have something, if you have some content in there, when user run this one, it might not work. So make sure that if you have some file paths, so this is particularly important if you have some file paths on your notebook. So number one, never use like C, colon, and slash or something like that on notebook. Is never going to work. Second, if you have a relative file path under, for example, some of you for your lab 8 or lab 9, I gave the comment that your notebook will not work if it run on Google Colab, because if you have your examples and then slash data slash doc something .geojson, it's never going to work, because when people open your Google Colab, the files are not being downloaded to the Google Colab computer. So the recommended way would be using the GitHub HTTP URL. So you want to HTTP URL blah 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 to the direct file path. In that way, it works fine. So one example would be like this. If I go to my leaf map here, right, notebooks, and then maybe how about maybe low raster or something. So something like this, right? So you either need to download the notebook to GitHub, or you want to directly pass the URL. So add raster, so don't use the file path otherwise, because Lab 9 has the add image function and the add raster function. So some of you the add image, and then in your notebook you have the file path. It doesn't work. It runs fine on your GitHub Actions on your website. It doesn't run fine on GitHub on Google Colab. So you can try it out. You try to run the notebook on Google Colab, it will not work. Okay. So you probably want to do is to, let me see if I can find an example here. Clip image, volume, add widget. How about this one, right? So leaf map has a function called add widget. I can add any widget to the map. So for example, add text. This one add the hardware to the bottom right corner, and you can change the style, so you can add any HTML. But I want to show you the last one here is this one, right? So for example, the logo, right? This is similar to add image function that we use for Lab 9. If you look at this one here, I'm passing the HTTP URL. I'm not passing your examples slash logo.png, right? Because it will not work if people open it on Google Colab, because the file doesn't exist on Google Colab. So everything here, if you try to run it on Google Colab, if the notebook has some file path, the file need to be showing up in here. If it doesn't, it's going to throw error, right? So the recommended way would be to have something on your GitHub, or you can have something as a direct HTTP URL, and in that way the file is always accessible. That's why, for example, I can add the logo, I can add images, I can add anything to the notebook, but it's still interactive. So you see here, right? Similarly, there's I think the add vector function. How about this one, right? So if you're trying to add shapefile, GeoJSON, and other stuff, look at this one here. See what it is, right? Notebook in GeoJSON, and this is the direct URL to the file path, right? So if I double click and look at this one, you want to see the content. So it doesn't matter where you run the notebook. You run the notebook locally, you run the notebook using GitHub Actions to build the Mkdocs website, or you run on Google Colab. It works seamlessly on all the examples. Yes?
Can you show again how you copy just the file path from our GitHub account?
Yeah. So here, for example, if you want to use any files, let me use the leaf as an example. So in your notebook, assume that you have some small sample data set in your directory. When you run this one locally, it's fine to have like examples, data, and then the file path. But eventually, when you push to GitHub, you want to make sure that you use this way. So examples, and then data, right? So here you want to have some files in here. Also, make sure that if you try some vector data, don't use the .ssp because they only point to just one component. If you're trying to add SSP to your notebook, to your map, you need all the files. This one doesn't work, so, but the GeoJSON work. GeoJSON is just staying alone, right? So if I click this one, and all you need is just click the lower button or right click, and then copy the link address. And this is the link that you want to use in your notebooks, okay? Mkdocs GeoJSON URL to this one. So if I click, you see, it's going to redirect. So either one should be fine. So if I paste in here, you see this one, GitHub, blah, blah, blah. If I hit enter, it's going to redirect. But you can use either one. So if I click, you see, it's going to redirect raw.github users content something. So if you want, you can copy this one and then paste this one into a notebook. And then you use this one, Mkdocs GeoJSON, extract file, vector. This one works multiple platforms because it's going to pull the content, right? But if you just use, for example, here, double quotes, example, slash, the file name .geojson, it works on your local computer. It works on the GitHub website building. It doesn't work on Google Colab because the .geojson file doesn't exist here. Make sense? And the other one you want to pay attention is if you're trying to use some vector data, if you assume that you have a CSV is fine because it's independent, just one file. But for shape file, it's not, okay? So never do like this, okay? I'm showing the mistake that you want to make, right? So .ssp, and then come here, raw, right? Double click, and then try to paste here. Don't do that, okay? .ssp, a shape file has multiple components. You need to have all the files. One link is not sufficient. So here, it will never work, okay? So this is what you need to do. There are a couple ways. You can either zip the shape file as a zip file, something .zip, and then within it you have the SSP, SB, SSX, this one, okay? This is what I'm talking about. That's why I have a .zip file in here. If you click in, and then click this one, right click, click the URL. This one is fine because when you pull the zip file, GeoPandas can read the shape file into HTTP URL, and then you can read the contents inside. In there, make sure that you have all the components in there, not just the .ssp. Otherwise, it's not going to work. So if I download this one to my computer, and then if I open it, you see, I have all the shape file components in there. So the take-home message is, if you're trying to demonstrate on your website, trying to deal with some vector data, GeoJSON, you can pass the URL, or GPKG, or .zip file, but never use shape file directly. It's fine on a local computer, but it's a bit complicated when you're trying to access the file on the internet. Of course, you can try to use some packages to download the file to GitHub, to Google Colab, but it's not very convenient. Again, you want to make sure that everything runs perfectly on the website, and the user can actually try it out using Google Colab. So you want to make sure that your things are reproducible. You see, I provide all kind of stuff in here, and if you don't want, I can click open this one. So usually in your notebook, the first line, you want to add something like this, so the user can accommodate to install a package. Most of you didn't. I mean, in the first couple of weeks, we did it, but when you finish the website, you want to make sure that you have something like this. So that, for example, when I'm doing the grading, how do I figure out whether your package works or not? I need to click your node. Some of you have the Google Colab. I can click, I can install a package. Some of you didn't. Some of you didn't have this line, so I actually have to pip install and then gig plus and then your URL, right? So it takes me a while actually to be able to grade your assignment because I need to look into the source code. I need to test it. But think about it. If you have a website like this, I don't even have to look into your source code because I can see the result directly, right? Because GitHub Actions take care of the checking all the notebooks, run all the notebook, and you can see the result whether it works or not. If you're using Folium, you can do it like this way. If you're using IPyLeaflet, like I changed the base method, this one doesn't really work. So I still have to test your source code. But anyway, so this is, for example, I can come here and check, and then I can just install. I need to sign in, right? And then I can run the notebook from the beginning to the end. So this is something you want to do for your package, especially when for your final project. When I go to the website, I say, oh, this is cool package. I want to try it out. How, right? I don't want to install your package, all your packages on my local machine, because you might include some like weird dependencies that I don't like. But I just want to try it on Google Colab and then click the link, boom, everything works fine, perfect. But if I click and then none of the notebooks works on Google Colab, it's a red flag, right? That means nobody will be able to actually use your stuff. So this is something you want to consider. When you put something out there, you want to minimize the barrier. You want to lower the barrier so everyone can try it out directly and they can play with it interactively. Okay, so this point I want to show you like some of the best practices for building a website, whether to execute a notebook or you want to ignore. And hopefully for your final project, I can see something on your website, right? Rather than I have to run it on my local computer to test it. If you have any questions, let me know or send email to the group. And I will see you on Thursday for the last lecture. We might talk about more about the Streamlit web app, how you can build some complicated one rather than using the template that I provided. Okay, so that's all for today. I will see you on Thursday.